heritage in telecom space, some survivors that we've got survived the telecom corridor in Richardson. Two main heritages, one in access networks from Siemens, and the other part of the groups is a company called NetSocket, which was one of the pioneers in the SDN space. So essentially what we're doing, it's a good segue from the previous presentation, we're actually working on the software for the networking underneath these applications that were just discussed. Essentially the hardware and the infrastructure for these networks, whether they're in the carrier space or they're in all these buildings that we're looking at and living in right now, has become very much a commodity. This push into SDN networking has been driven primarily by companies like Facebook, Google, Alibaba, all these companies that are developing their own software networks for data centers and moving away from proprietary hardware from the giants that we know, Cisco, Juniper, and Nokia. And the idea here is because the hardware has become a commodity, the software community grows with open source software and other components in order to build these networks that will then take us into the future. So our focus is primarily on the enterprise, two areas of creating virtual networks, purely software, so the users of the network are very much divorced from the hardware. Expertise in hardware is very expensive to learn, to maintain, very expensive technologists that you require to manage these networks. So what's going to happen over time is a significant amount of software for automation and the ability to deploy networks and not require you to have very expensive certified engineers building and managing these networks over time. So we have both software that supports multi-site routers, so a company with multiple locations around the world can then set up with simple all off-the-shelf hardware. We're strictly providing the software for these networks. Off-the-shelf hardware based on Intel x86 boxes and servers, switches that are primarily Broadcom switches. There's a group that was started by Facebook. There's one of the key starters called the OCP project, Open Compute. And this is a whole list of pre-designed hardware that they bid out to all the manufacturers to be able to build standardized hardware. So based on these components, we're building routers, we're building access networks, we're building distributions in buildings and then in small cities at this point to be able to create these networks all in an automated fashion. So the idea here is that the users of the networks want to provide services. They don't want to sit on a switch and type in commands on a command line interface, define ports, define VLANs, and all these things that are probably Greek to many people. They want to deliver videos to the endpoints. We want to deliver high-speed internet. We want to have Wi-Fi service. We want to have telephone service. We want to have video service. Just like your phone right now in your pocket has all these applications and services brought to it. That's all you care about is I need the service here. And now what's happening in this evolution with our software is we do this now on the actual infrastructure at the lowest layer. So similar topic, a lot of data usage, data storage, data distribution, that's exploding. So I'm not going to dwell on that, but the IoT and all these applications that we're talking about are causing an extensive growth and exponential growth of the needs for the networks underneath all of these applications and products. The existing networks, if you look out in the buildings and the streets, if you go downstairs, probably not this building since it's brand new, but there's a lot of disparate networks for delivering voice, for delivering video, there's copper infrastructure for all sorts of different things, really just getting the services to the end. So all this infrastructure is, 90% of the buildings you're looking at have telephone wiring going through the buildings. They have coax cable going through the buildings. And then of course they have now Ethernet cables going through for the data services. So the idea here is to collapse all of this infrastructure onto a single fiber network. The point is that all these applications are just that, software applications. All they require are very high-speed highways at the bottom, and the highways have to be reliable, secure, and able to be robust. So regardless of human interaction, regardless of any physical damage, that these networks will then take care of themselves, bring up the services, and keep running. So an example of these networks, I mentioned phone service automation, video conferencing, trying to simplify the deployment and of course lower the cost of both the CapEx and the operations for these networks. So the concept here, and this is the networking concept that the carriers, AT&T, Verizon, and all the telecommunications carriers and the cable companies are doing right now outside in the distribution to all the new cities, is being done now inside buildings. So you can bring all the services, building mini networks in buildings such as this size, hotels, hospitals, bringing these networks inside the buildings now. The costs are dramatically reduced for both optical fiber and for these components, which are now commodities. You're not going to be stuck with hardware vendors. So that as this evolution continues, all these companies have to be transformed into service companies. The hardware is separating from the software, and then the software is what's driving the network. Physical space in buildings, so the savings when you're deploying what is very expensive real estate space. You've got closets with servers, with wiring, gets significantly reduced by over tenfold by using optical cabling throughout the building. The distances, copper switches have a limitation of 100 meters. So in a building like this, you'll have switches every few floors, a lot of cabling going through the ductwork. In the optical distribution, you put one system, very small footprint in the basement in the MDF, main distribution frame room, and all of that is distributed through the building without any electronics. It's all passive fiber, install it, and it's done. No corrosion and no active gear that needs to be maintained. So space savings and less power. So the other part is because there are less components and less physical active gear, less cooling, and less electricity is used throughout the distribution. So the savings and the benefits, it's faster, better, cheaper, and lasts longer. I mean, all the things you want in the product. So optical unlimited bandwidth at the endpoints will just keep upgrading over time as technology improves. Right now, what's being developed are all 10 gig links at a pretty low cost throughout the networks, and 40 gig is what's currently being deployed. And this is 40 gig, 10 gig and 40 gig to individual users of the network. So clearly there's a lot of growth as we see hop skip as the networks grow, then the endpoints grow, then the end devices grow, and the access grows. So it's kind of a transition back and forth. And right now the devices are increasing exponentially, and now it's time for the networks to catch up with the end devices. So SD-WAN is a lot of companies in this space. We're specifically focusing on the local area networks as well as the wide area network. So the wide area network gives the company the ability to manage their systems anywhere in the world from one place using commodity hardware and making it much simpler as opposed to using VPNs and having disparate apps. It's an analogy to the previous discussions we just had, other than it's the network itself now that is a commodity across all the sites. So the team is long telecom heritage as well as a data center networking. We've been in this SDN space for about 3 years now, transitioning from more of a hardware vendor to a software supplier. And moving out into space, we're now deployed. Specifically, we have contracts with partners and going out to hospitality. So we're deployed in about 7 or 8 hotels right now, and have contracts for 4 more large enterprises, and are bidding on stadiums. So a great use case and example of this is Texas A&M Stadium. Is a pure optical laying infrastructure in there. It's a network designed to support 5 meg symmetric service per seat in the stadium. So everyone's walking into the football game, watching one game on their phone and watching another game on the field. So these are networks, if you think about it, it's used 8 times a year, and it's providing, terabits of data capacity just for the games. And these are all now cost effective because of the hardware being commodity, and then the optical distribution, which makes it all happen. Any questions?
So I guess the service providers like you, but the hardware guys don't like you.
Right. Yeah, the companies that can do this kind of infrastructure work are like, Nokia, Cisco, Juniper. Their cash cows are, what's preventing them from doing this right now. If you look at IBM 30 years ago to what they are today, going from big mainframe computers to a service company. So there's definitely limitations. Ironically, these are the same companies that are leading all the standards bodies for making the open source software, creating them and defining what these standards are, and spending a long, long time discussing how this is all going to come together. So the service providers, AT&T has been public, is one of the lead providers in the world who's fostering this design. They intend to buy the hardware directly from the factories themselves and develop their own software with a consortium of companies. That's a lot bigger, job to hoe. In our space, we've kind of come from the ground up. We've got a lot of experience at the lowest layer, delivering reliable networks, and we're not one of those big companies, so we're not kind of bridled by concern about cash flow from our existing business. But it's what's going to be the future. So they're all going to be changing. It's just a matter of how fast they move.
Transfer to converting towards the software platform that you're talking about. You were hardware before. You were primarily hardware before.
So we were providing in-devices components to the network, really the lowest layers of the endpoints is what some of the work we did within Siemens and the other companies. The NetSocket acquisition was the SDN multi-site router, and essentially going from the bottom up. So if you look at the data centers and all the SDN that was implemented in the data centers, it's a different environment in the data center. It's usually manned. It's a focused area where there's, I'd say, a lot of servers, a lot of traffic flowing, but a very tight network. When you get outside the buildings and the outside world, just a lot of moving parts and a lot of logistics and dealing with remote control of things that are 20 kilometers away. So it's a transition.
So did you ever follow suit with the transition?
So we're moving from hardware to software. So the software components are in growth phase right now. So it's a transition from our other businesses to our new business.
Are you looking for investment?
I'll move over to our CFO.
Right now, we have family offices in as investors so far. We're probably going to look for institutional money sometime towards the early to middle of next year.
Are you able to run market predictions?
On
How much is x86?
Sure. So we're at different layers of the network. So the essential thing and what the big hope is that we'll put all the software in the cloud, all the software that's far, far away, and the devices become very dumb. In reality, for a reliable carrier-grade network, you have to have some software on the devices. So we've got in our portfolio of end devices, really ARMS, MIPS, Intel x86, Broadcom platforms. That really, what we've done is abstracted enough layers up to the point where anyone can manage a layer 2 and above network without ever seeing a piece of hardware or understanding layer 1 technologies. And there's a lot of religious words about DSL, about GPON, about EPON and cable. The whole concept is nothing in our platform requires you to understand layer 1. It's just the services to the endpoints, and then the software we've built over the years that just takes it